In my previous two videos, I showed how you can calculate stress and strain for objects experiencing tensile, compressive, or shear forces. In this video, I wanted to go over an example problem. Suppose you're given the following problem where you're asked to calculate the stress, strain, and elongation for a 2-meter cube experiencing first a 75 Newton downward compressive force and then a 100 Newton shear force on its top face. You're told that this cube is made of aluminum. We know that in the first scenario, a 75 Newton downward force on the top face of the block will cause the ground to also apply a 75 Newton force in the upward direction. And in the second scenario, assuming that the cube is fixed to the ground, we know that a 100 Newton shear force across the top face of the cube will cause the ground to apply a 100 Newton shear force in the opposite direction on the bottom face of the cube. Because we know that the formula for area of a square is just side squared, and we're told that the length of any side of this cube is 2 meters, we can square this value to determine that the area of each face is 4 meters squared. This area also represents the cross-sectional area of the cube. And because we know that the formula for compressive stress is just the applied force divided by the cross-sectional area, we can plug in the corresponding values to find that the compressive stress is equal to negative 18.75 newtons per meter squared. Notice that because this is a compressive stress, our applied force needs to be negative. We can use a similar formula to find the shear stress in the second scenario. This is just simply the applied force divided by the area of the top face of the cube. Plugging in the corresponding values, we can find that the shear stress is equal to 25 newtons per meter squared. We know that the formula for compressive strain is just compressive stress divided by Young's modulus. And because we're told that the cube is made of aluminum, we can use a reference table to find that Young's modulus for aluminum is 70 gigapascals. This is just 7 times 10 to the 10 newtons per meter squared. Plugging in both Young's modulus and the compressive stress that we already found, we can find that the compressive strain is equal to negative 2.68 times 10 to the negative 10. Here we can see that strain will always be a unitless value. Similarly, in the second scenario, we know that shear strain is equal to the shear stress divided by the shear modulus. The shear modulus for aluminum is 24 gigapascals, or 2.4 times 10 to the 10 newtons per meter squared. Plugging in the corresponding values, we find that the shear strain is equal to 1.04 times 10 to the negative 9. We know that the formula for compressive elongation is 1 over Young's modulus multiplied by the applied force divided by the cross-sectional area multiplied by the original length. However, this is really just the compressive strain multiplied by the original length. The original length here is just the height of the cube, which we're told is 2 meters. Plugging in the correct values, we find that the elongation is negative 5.36 times 10 to the negative 10 meters. Because the cube is experiencing compressive forces, this represents a decrease in the original length, or the height of the cube. A similar formula is used to calculate the elongation in the second scenario, but this just simplifies to the shear strain multiplied by the original length. In this scenario, the original length is again just the height of the cube. And plugging in the correct values, we find that the elongation is 2.08 times 10 to the negative 9 meters. Now we can see that the elongation is larger in the second scenario. I hope that this video gave you a better understanding of how you can apply the formulas for stress and strain. It's really just a matter of plugging in the correct values. If you still have any questions on the topic of stress and strain, feel free to comment below and I'll do my best to answer them. If you found this video helpful, please give it a like and consider subscribing to the channel for more fast physics videos. Thanks for watching.